Okay, let's go ahead and fill in this table. So in between the sodium chloride and the sodium nitrate, what should I write? Na2S? Everybody okay with that? The charge on the sodium is +1, and the charge on a sulfur that's become an anion is going to be -2. So then I just need 2 of the sodiums to go along with 1 of the sulfurs. Okay, and the sulfate, what should I put for that? Since the sulfate and the sulfide, these two guys here, have the same charge, then the ratio should be the same for cation to anion. And then the last one? Na3PO4. Awesome. Love it. Okay. And what are we going to do for the next row? Same exact ratios because sodium and ammonium ion have the same charge. Okay, so then I need an NH4 parentheses 2S and an NH4 parentheses 2 SO4. And I forgot this one, NH4 NO3. And then an NH4 3 PO4. Are we okay with those? Questions, comments? We're all totally fine with the parentheses and everything. Okay. Next one. So it's going to be HgCl2. Why? The mercury's got a +2, so I'm going to need 2 of the -1 chlorines to go along with that. So HgS, since they both have a magnitude of 2, the ions, and then HgNO3 2, and then Hg, and then SO4. We need Hg3 PO4 subscripted 2. We good with that? If you're not, you should probably say something. Okay. So why is the formula CaCl2? Calcium's in the second column, so it's got a +2. So this mercury, this calcium, and this copper, they're all going to have the same ratios. They should look the same. So then I'm going to need 1 calcium for a sulfur. I'm going to need 1 copper 2 for a sulfur. I'm going to need 2 nitrates to go along with this calcium. I'm going to need 2 nitrates to go along with this copper 2. I'm just going to need 1 calcium and 1 copper to go along with the sulfate. And then Ca3PO4 2, just like above and below it. All right, so now the aluminum. So since it's in 3A, I have aluminum and it has a +3 charge, so I'm going to need 3 chlorines to go with that. And so Al2, 2S3, and then Al, and then NO3, 3, and then Al2, SO4, 3, and then AlPO4. And then this last one, this manganese with this charge of +7, So I've got Mn, and then I'm going to need 7 chlorides to go along with that. And I've got Mn2, and then S7. And I've got MnNO3, 7. And I've got Mn2, SO4, 2. Sorry, not 2, 7. And then I've got Mn3, PO4, 7. So for these shaded ones, write the formula of the oxidation number for each atom and name the substance below. All right, so for the first column, I've got HgCl2, and that's mercury 2 chloride, and it's Hg with a +2 charge, and chloride with a -1 charge. And then the second column, it looks like the Al2S3. Al2S3. So it's aluminum sulfide. And it's Al with a +3 and sulfur with a -2. Does anybody know how the rest of the world pronounces aluminum? Aluminium. Okay. We are literally the only ones that say it like that. So then I've got it NH4NO3. So it's just 2 polyatomic ions, so I just say their names. So I've got double M. Ammonium nitrate. And so inside of here, I've got, I'm going to go ahead and separate these guys into their constituent pieces. Makes it easier. So when I'm looking at this, I've got a hydrogen with a nonmetal. So the hydrogen is a plus charge. And that nitrogen that's with that is going to have to be an N-3 because the ammonium ion has a +1 overall charge. So there's 4 hydrogens giving you +4 and a nitrogen giving you -3, and then the ammonium has a +1 left over. So that worked out. And then the oxygen is going to be a -2 charge, gives us a -6 with a leftover 1, and then the nitrogen is going to have a charge of +5. Are we okay with that? And then the last one.
So with those, you always have to separate them out.
The
You can't just split the polyatomic ion and then put the charge for that.
No, because I asked you for the oxidation number. It says for each
Okay.
atom. Otherwise, that would have been okay. And then the next one is calcium sulfate. No, calcium, or was it copper? So CuSO4. So copper 2 sulfate. And so the copper one's easy, it's +2. The oxygen is a -2. And then that leaves us with the sulfur with a +6 charge. And then the last one is the calcium phosphate. So Ca3 PO4 2. So Ca with a +2 charge, oxygen with a -2 charge, and phosphorus with a +5 charge. We okay with that?
But if phosphate has negative
Yep.
charge,
Mm-hmm. So I've got a Ca +2, a Ca +2, and a Ca +2. I've got 1, 2, 3, 4, 5, 6, 7, 8 oxygens. -2, -2.
I forgot about that.
Say again?
I forgot about that. Being a lot of
Oh, okay. So I have all those oxygens, those 8 oxygens, those 3 calciums, and then that leaves me with 2 phosphorus. And so on the positive side of this, right now I've got 6 pluses, and on the negative side I have 16 negatives. So I would need 10 more positives, and so if I make each phosphorus a 5, then everything gets canceled out. So I'll make that a 5, that a 5, and then I'm good to go. All right, somebody give me an acid. HBr, hydrobromic acid. Okay, how about another one? H2S, hydrofluoric acid. So then I'm going to give you HBRO3 and H2SO4. So what are those names? Bromic acid and excellent. So how are we differentiating between the two, the hydrobromic and the bromic? Oxygen. So the oxygen's there, I don't get to say hydro, and the oxygen isn't there, I have to say hydro. So if you see hydrobromic acid, it's just the HBr, and if you see bromic acid, you got to think to yourself, there was no hydro said, so then that means this thing has an oxygen in it, and since it was bromic acid, that means I must be talking about bromate polyatomic ion, which is BrO3 negative, so then I just need 1 hydrogen on that. So then I look at the next one, and I see hydrosulfuric acid. So hydro is telling me no oxygens, and it's a sulfur, so the sulfur's charge is going to be -2, so I need 2 H's for that. Great. The next one I'm seeing sulfuric acid. So since it doesn't say hydro, it has oxygen. And since the acid's name ends in an ic, then the polyatomic ion it came from was 8. So then we're talking about SO4 -2 needing 2 H's to go along with the sulfate polyatomic ion to make sulfuric acid. Good? Write down 5 covalent compounds. All right, so give me a covalent compound.
CO2.
CO2.
Carbon dioxide.
Next.
CO.
Next. Okay. Nobody's ever going to call it that, but okay. Next. One more. Ammonium. Ammonia. Okay, so these two they're not following the rules for covalent nomenclature because they're so common. So, if you're gonna answer this on a test, you'd have to give me what the actual names are, which would be dihydrogen monoxide, and what's the next one? Nitrogen trihydride. Somebody's got an "ide" on them. Somebody does. And so in this case, it's the hydrogen. But again, nobody would ever use those. They would just say water and ammonia. Okay.